Good morning, everybody, and welcome to the webinar on Candy's Advanced Worksheet Functions. My name is Marnus Jans van Rensburg. I'm a Senior Technical Consultant here at the CCS Centurion office in Gauteng, a city in South Africa. It is my pleasure to present this webinar to you. Today, I'll be showing you the advanced functions of Candy worksheets. Due to the large number of people logged into this webinar, we will not be able to answer any questions during the webinar. However, please submit your questions during the session with the provided function on screen. At the end of the webinar, we will collate these questions and send the answers to everybody that registered for the webinar via email. Please note that the webinar will be recorded and you'll receive a link to download it. There's a webinar once a month on various Candy topics. Should you not be able to attend the webinar at the given time frame, then please register for the webinar, as this will entitle you to receive a recorded copy of the webinar. Let's get started. Okay, so the agenda for today's webinar is an introduction to advanced worksheets, and then we're going to look at applied factor, local and global variables, powers and exponents, square roots, negative values, trigonometry, system constants, if, and else statements, switches, rounding of values, and then macro price codes. So firstly, what is advanced worksheet functions? First principle estimating in Candy is done using worksheet pricing. These worksheets can have up to 200 lines of calculations and has advanced functions to speed up pricing process. In this webinar, we will show you all the functions and give you a deeper insight of the worksheet capabilities. Okay, let's have a look. The first one is applied factor. Now, applied factor is a common factor that needs to be applied to a range of resources on a worksheet. For example, you have a range of material resources that you want to apply a percentage rate of waste to. So instead of adding the waste to each individual line, you'll take the common factor, which is your waste, and you'll apply it as an applied factor. So let's go and have a look at another example. So over here, I have my advanced worksheet tools job. In this job, I have some items that I'm going to use for the webinar as my example. The first one, the applied factor, will be my clearance strip site, measured in square meters, and the rate is 3.39 per square meter. What I'm going to do is I'm going to open up the worksheet for this item. Now, you would have noticed that there's a common factor of 900 squares per day that I have on each and every one of these resources. Now, to have used the correct method would have been to use the applied factor. So to use the applied factor, I obviously need to take out the common factor that I placed on each item individually first, and then I'll insert a line above where I want the applied factor to start. I will then put a hash sign, and then below the last resource, I'll say equals divide by 900 meters squared per day. Meters squared per day. Now, what the system will do is everything from the hash to the equal sign will get the applied factor applied to it. My rate will still remain the same, but now I didn't have to go and type it in for each individual one. If a resource should have been excluded from the applied factor, you could have just used Control right arrow key to take it out. Or if there was a resource that you missed that should have been included, you can have used Control left arrow key to add it so that it's between the hash and the equal sign. So most important is just everything between the hash and the equal sign will get the applied factor applied to them. So if you think about it, if you had 10 resources that has a common factor that needs to be applied to them, it would be very tedious to go and type it for every one of them. And it also leaves room for you forgetting to add it to one of them. So the applied factor then takes care of that, where you apply it to all of them at once. So I'm just going to click here on store and return to document and then store my worksheet. Next item is then local and global variables. So local variables is variables that are used locally within a worksheet, and global variables are variables that you define under definitions and settings, and that can be used globally throughout your job to do calculations. So the first item here, I have excavations for foundations 6 to 8 meters deep. I'm going to double click on the rate and open my worksheet. So the plan here is to use some local variables to calculate my production instead of having my plugged in 400 cubes per day value there. I'm going to add a few lines. I'm going to add a heading, local variables local variables, and I'm going to start defining my variables. So variables you define in block brackets. The first one will be 0.5 cubes, and that is my bucket size. So I went to our site, or I went to our plant yard, and I checked that the CAT 215 excavator's bucket size is 0.5. I then investigated this excavator for an hour, and I noticed that in an hour it does roughly 120 cycles per hour. I then obviously just know that we work 9 hours a day, and I then have my E, which is equal to 0.8, and this is then my efficiency. So what this variable is for is I'm pretty much just saying that out of the 9 hours a day, my team is only effectively working 80%. So the rest of the time is standing time for the machine, tea breaks, lunch times, etc. Then I have bulking factor, which I'm going to be BF equals 1.14, and that will then be my bulking factor. For those of you who don't know, bulking factor is simply when you are excavating compacted material, a cube of compacted material is more when it's no longer compacted. So once you've excavated it. So we add the factor there to keep in mind for that bulking factor. Then I'm going to add a variable CAT 215, and that's going to be equals to 1. This will then be my number of excavators. All right, next I'm going to calculate my production. So P, which is my production, is going to be equal to round bracket, the size of my bucket, times my cycles per hour, times my hours per day, times my efficiency, divided by my bulking factor, times my number of excavators. So to make sure the values are all correct, you can hover your mouse over them, and I can just say here that this is my production. Enter, it gives me a value of 378. I can also put a question mark with a P, and the value will then be displayed on my worksheet. Now I need to go and replace all the values down here with the local variables that they require. So the first one would be to multiply my excavator with my number of excavators. Then I can also remove the 9 from my labor calculation and add the H. Now you'll notice the values for now, it's still the same because I haven't changed anything, 25.29. If I remove this 400 and I replace it with P, which is then less, it goes up to 26.69. So in my opinion, this is a lot more accurate than the thumb-sucked 400 cubes per day. I calculated a rough estimate of what my production would be, and I then use that as my production. What I can then do is 26.69, I can then say this is a time-sensitive item. So if I have 2 excavators on site, what's going to happen? It's going to go from to 26.05 from 26.69. So you can then use these local variables to manipulate the value and see the effects on your rate. So that is then local variables. I'm going to store this. Next is then global variables. Global variables, I'm going to open this worksheet. I have laborer here, and I multiplied it by 8 hours per day. Now, this means that everywhere where I use my laborer, it means I need to multiply with my 8 hours a day. Now, if there's something which happen and your number of working hours per day changes, then you had to go to each and every individual item to change it. So I like using labor as an example for the global variables, because a better way to have done this would be to go to your definitions and settings, number 2.4 global variables, and I'm going to add a global variable working hours per day. I'm then going to call this working hours per day, and this is then hours, and I'm going to make the value 8. So the code, the description, the unit, and then the value. Click on OK. On my worksheet, I will add a question mark, working hours per day, and there you'll see it's 8. So what I'll then do is I'll replace that 8 with working hours per day, and you'll notice the value still remains the same. But now I use working hours per day in all my worksheets. I get a notification that I need to change from 8 to 9. So I can just change this 8 hours a day to 9 hours a day. Click on OK. The value 3.39, once I click on this worksheet, that becomes 9, that becomes 3.47. So now you can rest assured everywhere where you used your hours per day has been changed, and all your rates will then be updated accordingly, which would save you time and also make sure that you haven't missed any of the items. I'm going to click on Store Worksheet. Next item then on my list is Powers and Exponents. So for Powers and Exponents, I have this item, bulk excavations for basements. So it might have happened that you had to do in a previous estimate, you had to do a calculation where you had to go get your calculator and calculate the value because you weren't aware of the fact that you could have done it in Candy. So what I'm going to do is I have my length variable already defined here. So I had it predefined just to save some time. That is the length of my excavation. Then I have the height, so that's the depth of my excavation, the h, and then I have the t, which is the tangent. So I know out of experience, this tangent line is normally about 12 meters long. So that's why I'm using 12 there. So what I'm going to do in this example, I'm going to use these values as well as my exponents function to calculate the value of A so that I can calculate the volume of this triangle. Now, what is this triangle? Normally in construction, they want you to dig out a perfect cube for your basement, but this is not possible. So you have to do it at an angle. Normally we call this overbreak. So this overbreak is most of the time not being paid for. So what I want to do is I want to calculate the volume of these two triangles for the overbreak to calculate a percentage to add to my rate for my overbreak so that I can have a bit of an allowable for that. So what I'll do is I now have my length, my length, my depth, and I have my tangent line. So what I'll do is I'll say that A2, which is just my base to the power of 2, equals round bracket t to the power of 2. So that's how you do the powers of, you do that symbol and then the power you want, minus h to the power of 2, close my bracket. And then for those of you who weren't aware, this formula that I'm using then is Pythagoras. Enter, it gives me a value of 108. I can then do question mark A2, enter 108. Then I took my calculator and I calculated the square root of that value and I got 10.39. So that is then the base of my triangle. I will then go and calculate the volume of my triangle. So the volume of my triangle is V equals a half times my base times my perpendicular height times my length. And that is then 779. I then say that that is my volume. If I want to see that value again, question mark, enter, then I'm going to do V2 because there's two triangles, and V2 will then simply just be my volume multiplied by 2. And that gives me a value of 1558. I will then just say that this is my volume times 2. Again, if I want to view this on my worksheet, I'll do that. All right. Last, I'm going to do a variable called O percentage, and that is going to be equals to my V2 divided by 1,800, which is my bulk quantity over there. And that would then be my multiplied by 100 to make it a percentage, and then that would be my over break percentage, 86%. I will then say question mark O percentage, enter, and then I can go to the supplied factor and say plus my over break percentage, as a percentage for over break to the rates. So currently it's 16.14. Once I hit enter, it gives me 30.11. So now I know I've made an allowable for the overbreak. I can then click store worksheet. Next is square roots. So you might have wondered why I calculated the value of A using my calculator and not did it in Candy. And the reason was so that I can show you the next step. So in this worksheet, I have exactly the same item, so I don't want to reinvent the wheel. I'm just going to click here on insert worksheet. It's going to insert the last worksheet that I stored. I will then say that A is not 10.39. A is actually round bracket SQR round bracket block bracket A2, which is then the Pythagoras value that I calculated there. And then I'll close my brackets and press enter. I get the same 10.3923. I can then also insert question mark A, and now I calculated A using my square root. The value still remains the same, 30.11. Store worksheet, and next item, negative values. So it might happen that you have a item somewhere where you need to deduct. So you need to have negative values. So to do negative values in Candy, I'm going to show you a full-fledged example of one, and then I'm going to show you a quick example of the other ones at the end of the webinar. So the first one is my 220 brick walls, clay brick walls. I have it priced there. You see there I have my superstructure bricks. I have my bricklayer teams, etc. Then I have an item for extra over face bricks. So I need to go and deduct from my clay bricks. I need to go and deduct for my stock bricks. From my face bricks, I need to deduct my clay bricks. So what I'll do is I'll add just another comment here, DDT for deduction, and then I'm going to add the resource. So I know the resource code is MV1020, and that is my bricks then. I need to then multiply this bricks by my local variable bricks, which is defined up here as 52 bricks per square meter. And I then need to divide it by 1,000 to convert that 1,000 to a per brick value. And then I'll put block bracket minus in block brackets, and then you'll see it negates the value. I will then add my labor resource, which I know is LAB 0005, enter, bricklaying team, and they work per shift. So I need to multiply my shifts with my number of bricks per square meter, and I need to divide it by my output, which is a variable up here, which is how many bricks they can do per shift. And I need to then multiply this by my A, which refers to my if statement down here. And I need to also put a minus in block brackets. And then you'll see it deducts 542.04 from that. So that's then how you can do negative values. I'm going to store that worksheet, and that is then my negative values. Next, we have sine, cos, and tan. So what I'm going to do is go into the next worksheet to show you the trig functions. So what I have done is, if you open this up, I have made a little drawing over here. I said I'm going to use my tan formula. So there I have the value of B times tan B is equals to A. I already filled in here that B is my tangent, my rest angle, that's 30 degrees. My L is the width of my excavation, that's 2.8. My H is my total depth of the excavation, which is 2. And then C is the depth of the excavation without batter. So what I'm going to do is I'm going to calculate a value to add to my applied factor to use to accommodate for the battering. So similar to what I did for the overbreak. So what I'll do is I'll say that now that I have that values, I want the volume of my C, which is equals to H minus C to the power of 2, that's the value then to get the value of D, times tan D. Close my bracket, enter 1.29. So this is then the volume of material in batter per meter. Now I want to know what is my volume of my measured work. So that would be simply my H times my length times width. So H times L. And that is then volume of measured material. Enter. 5.6. I can then say that my factor that I want to use for the battering, PF, equals my volume C divided by my volume M times 100 to make it a percentage, and that would then be my batter percentage. Enter. It's complaining that the price code is missing a bracket, and the bracket that's missing is I didn't put the bracket there in the front of vol C. Now, when I select here and I press enter, I get a value of 23. I can also then add a question mark, PF 23, and I'll then go and also go here, say plus PF percent for batter. 16.11 becomes 19.88. Okay, so that's then an example of using trigonometric functions to do a calculation in your worksheet. Next, I have system constants. So we have two systems constants. The two systems constants, I'm going to use this 25 MPa concrete columns, 3 meters high, 600 millimeter diameter to explain the system constants. If I open up this worksheet, there I have already typed in my system constants, the two of them. The first one is PI. That refers to pi, which you use for circular calculations, 3.14. The second one is SD, which is steel density, and that is used for steel structure calculations in warehouses, for example. So I already created some variables here just to save a bit of time again. So the first one is height. That's the height of my column. The diameter. Then I said my radius equals the diameter divided by 2, and then I have my radius there. So what I'm going to do now is I'm going to say the volume of one column is equals to Pi times my radius. So this is the volume of a cylinder calculation to the power of 2 times my cylindrical height, which is h. And I can then press enter. I get a value of 0.84, and that is then my volume. I will then go to my 25 MPa concrete price, and I'll say that that price per cube needs to be divided by my volume per column. Press enter, get my new rate, store the worksheet, and that would then be my price per column. Okay, so that's my system constants. Next, if, else, if, and else statements. So the best example that I could think of for this item is if you have a labor-only brickwork subby, and he charges you a rate per day that is different for lower quantities than higher quantities. You could do this if statement. So I have an empty worksheet here, and all I'm going to do is I'm going to say that my variable A equals 1,500, and I'm going to say that this is my meter squared brickwork quantity. Then I'm going to say that my C value is equals to if round bracket A is larger than 1,000. So if A is larger than 1,000, then C will be 900, else it will be 1,800. And then EIF to complete the formula, and I'll press enter and I'll get a value of 900. If I want to view my C value, remember I can do question mark C, and then I'm going to add my resource for my labor only brickwork subby, which is 90,000. I then have that, and I'm going to multiply that by my C per day. Now let's say that I'm doing a tender and I'm doing a new tender, and in this tender it's a small project. This value is only 500, so I then change that to 1,500 to 500, press enter, and the system will then automatically change my rate per day for my labor only subby. Store worksheet. Next item on the list then is switches. So switches, the best example to use to explain that is my concrete items. So I'm going to open this up. I priced this item to do batch concrete, but I want to add a switch to have ready mix in here. So I'm going to add a comment here, ready mixed, and I'm going to add my ready mix concrete. So my ready mix concrete code is 51143. There's my 25 MPa ready mix concrete. Now I want to add a switch so that I, as the estimator, can easily switch between site batch concrete and ready mix concrete. So how that switch works is it works with the global variables. So I'll go to my global variables, and I don't need to define it. It's already here. So I have a global variable defined already, just again to save time. If it wasn't there, I would have just added it to the end of the list. So I have a global variable defined there, RMC. If it's 0, it means it's batch concrete. If it's 1, it means it's ready mixed concrete. It's a switch, and currently it's 0. So I have it already defined. So what I'll do is I'll just click on OK. On my batch concrete, I'll add a line to do an applied factor. And I will then say that my batch concrete needs to get the following factor applied to it, and that is round bracket multiplied by round bracket 1 minus RMC, close my bracket, and remember RMC is a global variable, so it needs to be in block brackets. Press enter, and I'll get a value there, which is the total of my batch concrete cost. I can then say my ready mix concrete needs to be multiplied by RMC, and press enter, and that will then be 0. So what the system is simply saying is 1 minus 0 remains 1. So all this values times by 1 gives me the cost for the batch concrete. Now I get a notification from the client. I have to use ready mix. So how is this going to affect my estimates? I quickly go to my global variables. I go to my ready mix switch. I change it from 0 to 1. Click on OK. Open the worksheet again. And now it switched the cost to my ready mix concrete. And that is then switches. I'm going to store that worksheet, go back to my PowerPoint. Next one is rounding my values. So rounding the values, I have this item over here. For an example, I open it up, and what I have here is I have a length, a width, and an area calculation. The length times the width, and that gave me 23.41. Now let's say you had to do an area calculation, but you wanted to be rounded using the 4 to 5 rule. So if you want it to be rounded, I'm going to do another variable here, area. I'm going to say it's equal, and instead of saying length times width, I'm going to say round bracket RND round bracket length times width, close my brackets, press enter. It's going to give me 23. So if I add a question mark here, area, sorry, it's just complaining about that slash that I put there. So I'm just going to replace it with the correct bracket. And there I have my 23 rounded using the 4 to 5 rule. So that's then rounding values. I can then store my worksheet, go back to my PowerPoint. Next is macro price codes. So macro price codes is actually a mini bill inside of a bill item. So for example, the best one to use is manholes, and that is 1,000 by 12,000 by 15,000 millimeters in depth. So that is my manhole information. To identify a macro price code, it will always start with a number, then the trade. So this will be 9 and then an L for plumbing and drainage. Your macro price code uses a level structure just like your level headings in Candy. So a 9 will be your most basic manhole or macro, sorry, and a 1 would be your most complex macro. If you want to use a macro within a macro, you need to go one level down. So to use a 9 within a macro, you would have to create a level 8 macro. I will then create a code there. So it's 9 to identify it's a macro price code, L for plumbing and drainage, and then the rest is just the code that I added. You'll see the system generates that price code then. And if I double click on this rate, you'll notice it looks slightly different to what you should be used to what a worksheet looks like. So at the top here, you have your variables, which you can then use for calculation purposes. So I'm just going to fill this in. So this is going to be 1, this is going to be 1.2, this is going to be 1.5, and this is going to be 0.15. This name for this item would then be my width. This will be my breadth. This will be my depth, and this will be my slab thickness. Okay, now for the macros, you need to have price codes ready to price this item. So a manhole consists of excavations, concrete, brickwork, plastering, galvanized steps, etc. So there's a lot of bill items that go into this item, and all of them have different quantities. So therefore, the macro price code is ideal for pricing this. So what you would do is you would go to your P for your price code list, and you'll add a price code P1001 for earthworks, and this is my excavation for manholes per cube, and I'm going to double click on the rates to open up the worksheet, and then I need to price this. So I'm going to use the unskilled labor. I'm going to multiply it by working hours per day, and I'm going to divide it by 1.5 meters cubed per day. That gives me a rate of 206 per cube. I'll then store this worksheet. Then I need to go on my worksheet and go and find that excavation for manholes, drag and drop it onto my manhole, and then you'll see it adds that price code to my macro price code. I'll then go to the quantity and I'll calculate the quantity for my excavation will simply be my A variable multiplied by my B variable multiplied by my C variable. And that will give me a value there with a total amount. Next, I'll do my concrete. So the concrete for manholes, I have already priced it. So I'm simply just going to drag the price code in there and calculate the value. So the value will be A in the formula column will be A times B times D, which is my slab thickness. And so you will continue, you'll add your brickwork, your plastering of the manhole, your galvanized steps, etc. And then when you close the macro, it will then have a price per item. Next, I'm going to just show you some more advanced worksheets. So the first one is pricing a manhole in a worksheet. So what this looks like is like this. I have my width, my breadth, my depth of my manhole. I have my overall width, my overall breadth there. I have my slab thickness. Then I have my excavation, my concrete, my reinforcing, my formwork, my brickwork, my benching, my plastering, etc. Priced using all those resources as individual items to price my manhole. Now, this is not the recommended method. We do not recommend you use this at all because of the post-tender efforts that this creates. If I store this worksheet, the best way to price a manhole is using the macros, and I'm going to show you why now. I'm going to double click on this. This is then a completely priced manhole using a macro price code. So I then have my excavation, my concrete, all of them has their different quantities. Once I close this, this is then the best way to price items that are similar or the same as manholes. The reason for that is once you get to post tender and you're using Candy for post tender control, you can right click on this manhole, you can select explode the macro without recoding. What it will then do is it will create internal items underneath that item with all the items that that manhole has been priced with. So you can then individually progress your individual items for your manholes and then use that to progress your number quantity. So because the manholes are measured in numbers, if you have 50 manholes and you claim that this month you've completed 15 of them, is all 15 of them complete, or is 15 of them excavated, 10 of them has been excavated and the concrete has been completed? So to have more accurate allowable, you can then explode the macro and then you can calculate next to each item how many cubes of manhole excavations I've done, how many formwork for manholes I've done. Then you can take that cumulative value, convert it into a value per number, and then you claim that 14 manuals is complete, and therefore your values will be more accurate. So that is then the end of the macros. Next, we have a worksheet with more if statements. So just to show you, you have if then else. You can also just have if a value is less than 10 and less than b, then it needs to be 500. Or you have if or then else statements, or you have if then else statements. So that is just a more detailed, more advanced example. I do not have the time to do that level of an example in a webinar, but if you want more information, you can contact us. Then we have examples of mathematical functions. So I'll open this one up. Here we have simple just sine, cos, and tan calculations. So if you want to calculate sine 30, it will give you the value there. Cos 60 gives you the value there. Tan 60 gives you the value there. Then you have more examples of exponents. So if you do 4 to the power of 3, the system will give you the value. 4 to the power of 2, the system will give you the value. As well as the square root of 16, will the system give you the value of 4. You can also use the term integer to convert a value into an integer value. So for example, 4.14 will be converted to 4, 5.67 will be converted to 5. And then you can use that to do an area calculation that would be a rounded value. So that's just a different method of doing that area calculation I showed earlier. Then over here, we have that exact same example that I did for the area calculation. The one has all the decimals, the other one using round, then rounds the value using the 4 to 5 rule. Then you can also do absolute values. So this will use the negative value of 4.13, or you can use, so the absolute value of that would then absolute there, you have ABS. This will make use of the absolute function and the values will be positive. So absolute values will just make negative values positive. So that's absolute values. Then the system constants, I already did that. The area of a circle, I showed that example. And then mass reinforcing bar, you can then calculate using that method where you say the reinforcing bar pi times the steel density times the diameter divided by 1,000 to the power of 2 divided by 4 will give you your mass of bar per kilogram meters. So that is then the example of using the SD. Again, I do not have the time to go into all these details, but I can show you that it does exist, and I already have given you a bit of an idea how it works. Next, I have my examples of converting negative values. So I showed you this one where at the end of your calculation, you just add a negative in block brackets. You could also multiply with a -1 in round brackets, or instead of using the negative sign, you could have used any G. That also works. So there's 3 methods of doing negative values, or you could have used the applied factor and multiplied by a -1. So that is then another way of doing the negative values. Last 2 worksheets is then another example of rounding. So this one, The first one is the one I showed you already. That uses the 4 to 5 rule. Then you have the second one, which uses round up. So that's quite nice. If you do round R&D UP, it will not round to 23. It will actually round it up to 24. It will always round up. Or you can do round down. So round DN, R&D DN, the same calculation there, and that will then round it down. So that's the different methods of doing rounding. The last example then is a floor and a ceiling rounding function worksheet, and this worksheet is very advanced. So we have variables here, which is A, B is my ceiling, which is A, 5. Then I have C, which is A times 1,000, and there I have my question mark values. Then for the floors, I can then say that question mark floors A, 1, that will then round it to the first decimal. The same goes for the ceiling, so CEL A, 1, that will round it up because you can't, you need to have the round up value for the ceilings, example. So this will round X up to the greater or equal integer of the significant positive integer, so that integer that you put in there. And then you have round down, which is just another way of rounding values down, different to the one that I just showed you on the previous worksheet. And that is then the end of my webinar. I trust you now have a deeper insight of CCS's capabilities of the advanced worksheets. I thank you for your time, and I trust that I will see you again. We will keep you informed on the next webinar. And if you are unable to attend, remember to please register for the webinar, as you will receive a copy of the recording, which you can then view at a later time of your convenience. Have a great day. Thank you and goodbye.